All right, so to review for the test, what I did is I went through the book and picked out some problems in the section on trig identities that are very similar, not identical, but very similar to what's on the test. All right, so one of the first identities I want to look at is number 73 on page 200. Okay, so this identity says that 1 over 1 minus sign plus 1 over 1 plus sign is equal to 2 secant squared theta. Okay, so what's on the right, that's our end result. Okay, we're not gonna do anything with that. We're just gonna leave that, and we're gonna try to change the left-hand side somehow into the right. All right. Well, first thing I'm noticing is that both denominators are similar. The only difference is one is minus sign and one has a plus sign. Okay, those are conjugates. So if we find a common denominator, chances are we're gonna get some nice things happening. Okay, things are gonna cancel out. Okay, so my goal here is to find a common denominator. Okay, one way to find a common denominator is just to take the two that you have, 1 minus sign on the left, 1 plus sign on the right, and multiply those together. Okay, so now I look at the fraction on the left. Okay, it has a denominator 1 minus sign. It's missing the denominator 1 plus sign. So I'm going to multiply top and bottom by 1 plus sign. Now the fraction on the left has the common denominator, 1 minus sign times 1 plus sign. Okay, now look at the fraction on the right. It's missing the 1 minus sign. So I'm going to multiply top and bottom by 1 minus sign and 1 minus sign. All right, so now let's do it out and see what we get. Okay, when I distribute in the top, on the left, I get 1 times 1 plus 1 times sine. Okay, on the right, when I distribute, I get another 1 times 1, right, plus, or actually, sorry, this time it's going to be minus 1 times negative sine. Right, so now we have a plus sine theta and a minus sine theta. Those cancel out. Okay, in the top, we just have a 2. Okay, that 2 is probably going to be related to that 2 right there somehow. All right, let's keep going and see what happens. So we get 2 divided by, and now we'll FOIL what's in the bottom. 1 times 1, 1 times sine, 1 times negative sine, and lastly, negative sine times positive sine. Well, a negative times a positive is a negative, and sine times sine is sine squared theta. Right, again, we get this plus sine minus sine. Okay, so that cancels out, and we're left with 2 divided by 1 minus sine squared. Right, last thing we have to do is look at this bottom, and we have to recognize that as a trig identity rewritten. Okay, so we learned this trig identity, sine squared theta plus cosine squared theta equals 1. That's what we have in the bottom, just rewritten a little bit. I'm going to minus sine squared. Watch what happens when I rewrite this identity. This cancels out, and I get cosine squared theta equals 1 minus sine squared theta. 1 minus sine squared theta here is exactly what I have in that denominator. And there's a simpler way to write 1 minus sine squared, okay, based on that identity I just rearranged. 1 minus sine squared equals cosine squared. So now, what I'm going to do is, instead of putting 1 minus sine squared in the bottom, I'm going to put what it's equal to, cosine squared. Okay, if you want, you can separate this out into 2 parts. You can write it as 2 times 1 over cosine squared. Right? Now, if we were to multiply these back together, you would get 2 times 1 is 2. That would be in the top. And 1 times cosine squared would be in the bottom. The reason I did that is because I want to point this out. 1 divided by cosine squared. Okay? In our reciprocal identities, we know that 1 over cosine is secant. Well, we talked about using these identities with higher powers. So 1 over cosine squared is secant squared. So now, instead of writing 1 over cosine squared, I'm going to write what it's equal to, secant squared. So I get 2 times secant squared theta, which is exactly what we were supposed to get from the beginning. 2 times secant squared theta. Okay, so again, it takes a little bit of practice to go through these identities and get used to them, but we're using the same basic rules every time. Pythagorean identities, reciprocal identities, no quotient identities in this one, finding common denominators, changing to sines and cosines, although we didn't have to do that here, and those basic tricks are what we use every single time. Okay, so take a look. You might have to watch this problem a couple times before it makes sense, but try to go through it with me once, and then try going through it on your own. All right, here's another one we'll take a look at. This is number 45 on page 200. It says secant over cosecant plus sine over cosine somehow reduces to 2 tangent theta. Okay, a couple choices how we could start this one. We could try changing everything to sines and cosines. Okay, see what happens. Or we could try writing this with a common denominator. Okay, this time, I'm going to try writing things as sines and cosines. Okay, here's my reason why. Look at this part right here. Sine over cosine. If we go back to our quotient identities, sine over cosine, we know is tangent. Okay? Well, the final answer is not tangent, it's 2 tangent. So if this is tangent, somehow I bet this is tangent. So when I add tangent plus tangent, I get 2 of them. Right? So I think changing sines to sines, everything to sines and cosines will help us see that. Right? Let's start with secant. Right, so secant, we write it using our reciprocal identities, and that's 1 over cosine. Okay, cosecant is 1 over sine. And for now, just leave that as sine over cosine. Okay, now on the left here, to divide a fraction by a fraction, I take 1 over cosine, I take what's in the bottom, I flip it, it's the reciprocal, and I multiply. So now 1 over cosine divided by 1 over sine becomes 1 over cosine times sine over 1 plus sine over cosine. Okay, next I'm going to multiply together right here. So I have 1 times sine in the top. I get cosine times 1 in the bottom. And then I still have the other sine theta over cosine theta. And now, again, using our quotient identities, sine over cosine is tangent. Another sine over cosine is another tangent. And when I add them up, I get 2 tangent theta. Okay, which is exactly what we were supposed to get. Here's another one that's similar to what's on the test. It says sine theta times cotangent theta plus tangent theta equals secant. All right, 2 choices here. Okay, we could change to sines and cosines first, or we could distribute first. I would distribute first and then change to sines and cosines after. So you're going to have sine theta times cotangent theta plus sine theta tangent theta. Right, so we just distributed sine to cotangent and sine to tangent. Okay, now I would change everything to sines and cosines. If you want, you can write that with a denominator of 1. Okay, cotangent we write as cosine over sine. Again, sine, if you want, put a denominator of 1. And tangent is sine over cosine. Right, so now in the first fraction, we can cancel out sine from the top, sine from the bottom. Okay, we're just left with cosine theta over 1 plus sine squared theta over cosine theta. Okay, now here what I would do, since everything is already sines and cosines, is find a common denominator. Okay, easiest way to find a common denominator is to take the two denominators that you have and multiply them together. Okay, so the fraction on the right already has the common denominator. So we're not going to do anything to the fraction on the right. The fraction on the left, well, I'd have to multiply both top and bottom by cosine theta. Okay, when I do that, I'm going to get cosine squared theta on the top, cosine times cosine. Now, this is where we have to recognize the Pythagorean identity in the top, sine squared plus cosine squared. Okay, even though this one is written as cosine squared plus sine squared, it's the same thing. So cosine squared plus sine squared is 1 over cosine. And now my last step, okay, use a reciprocal identity. When you flip the cosine, that is secant, which is exactly what we were supposed to get. Okay, here's another one that's not in the book, but it is similar to what's on the test. So let's take a look at it. It says cosecant theta times tangent theta divided by cotangent theta is somehow equal to tangent times secant. All right, so this is definitely one where I would change everything to sines and cosines. So we have cosecant becomes 1 over sine. Tangent becomes sine over cosine. And that's all divided by cotangent, which is cosine over sine. Okay, now at this point, what I would do is instead of dividing by cosine over sine, we have a fraction over a fraction. We're going to flip what's in the bottom and change it to multiplication. So we have 1 over sine times sine over cosine times another sine over cosine. Now, let's go back and look at the final answer. The final answer has a tangent in it. Okay? So, since the final answer has a tangent, why don't we just leave one of these sine over cosines alone? Because I know one of them is a tangent, so maybe we didn't need to change it, but I think changing it would help you to see that something cancels out. This and that cancel. All right, so you do need to change to sines and cosines to see that that happens. Okay, and now on the left-hand side, you're left with 1 over cosine. Okay, on the right-hand side, we have sine over cosine. And what I'm going to do is just switch the order that we're multiplying these in. It's the same thing as doing 2 times 3 versus 3 times 2. All right, so sine over cosine, that's my tangent. And 1 over cosine, that is my secant. Okay, so that one actually very easy, just changing to sines and cosines. We get our final answer of tangent times secant. Okay, and last one. Okay, this one is very easy if you notice the trick right away. Okay, if you don't notice the trick, okay, what you might start trying to do is use a Pythagorean identity, okay, right off the bat, because you're seeing cosecant squared and secant squared. But that's going to be kind of hard. You might say, oh, well, we have 2 different fractions, different denominators. Why don't we find a common denominator? Again, you could find a common denominator, but it's really going to make it a lot longer than the problem has to be. Also, changing things to sines and cosines might be the way to go. Okay, I think that's going to be the way to do it, but maybe not exactly the way we're used to. Okay, so let's start with this cosecant squared. Okay, from our reciprocal identities, we know that 1 over cosecant is the sine. So let's use this same identity except with a higher power. 1 over cosecant squared is sine squared. Okay? So that's what this first part is. It's sine squared. Now, 1 over secant, we're going to do exactly the same thing. We know that 1 over secant, okay, is my cosine. 1 over secant squared is my cosine squared. Okay? So now 1 over secant squared becomes just cosine squared. And now we're basically done. Sine squared plus cosine squared, that is a Pythagorean identity. Sine squared plus cosine squared is 1, which is exactly what we're supposed to get. Again, it seems very, very simple, but if you try other methods like common denominators, other things, you're going to wind up doing a lot more work and probably get stuck. All right, so always try to look for the most obvious thing you can, which again does take some practice. But hopefully these problems were helpful, and they're very similar to the kind of identities you're going to see on the test on Friday. All right, so last thing that's going to be on the test has to do with area of a triangle. Okay, so remember we talked about 2 different formulas for finding the area of a triangle. All right, so suppose I give you a triangle and I give you sides of 4, 5, and 6. Okay, this is the kind of problem where you'd use Heron's formula because you know all of the sides. Okay, that would be the quickest way to do it. Okay, versus a problem where I gave you a triangle like this, you know a side, an angle, and another side. Okay, this is the kind of problem where you do 1/2 the product of the 2 sides times the sine of the angle between the sides. Okay, again, half the test will be on these triangles, half will be on the other trig identities. I see you still watching the video. Well, that's good. It could pay off. So I decided to put a bonus question at the very end of the video. Okay, the bonus question is going to be to simplify cosecant x times tangent x squared divided by secant x. Right. What I'm going to have you do on the test is write down your answer to the above problem. This actual problem will not be on the test. Okay? So you need to copy down just your answer to this question onto your review sheet. You can use your review sheet on the test. Okay? So simplify that problem, write down your answer on your review sheet. On the test there'll be a spot that says bonus. Write the answer in right there, and if you get it correct, I'll give you 5 points on the test.